Welcome back to the deep dive. It is Friday, February 13th, 2026, a date that, historically suggests bad luck, superstition, and maybe a masked villain or two.
Uh-huh.
But today, we aren't talking about slasher movies. We are talking about something potentially much scarier, but also, I think, much more important for the future of business and security.
That's right. Although, depending on who you ask in the cybersecurity world, the current landscape of artificial intelligence it can feel a bit like a horror movie if you aren't prepared for it.
Perfectly put. Today, we are doing something a little different. Usually we take a wide-angle lens, we look at trends, we look at the big picture philosophy.
Right, the 30,000-foot view.
Exactly. But today we are zooming in. We are putting on our instructor hats. We are going to treat this session like a masterclass designed specifically for the learner. That person listening who needs the nuts and bolts, the actionable details, the stuff they can actually take into a strategy meeting on Monday morning.
We are getting granular. We're diving into a document that is effectively going to shape how organizations handle AI security for the next decade.
And what document is that?
We are talking about the NIST Cybersecurity Framework Profile for Artificial Intelligence. Specifically, the initial preliminary draft that was released back in December 2025.
And just to orient everyone, because the world of NIST can be a real alphabet soup of acronyms.
Oh, it can?
This is the Cyber AI Profile. It's designed to sit right on top of the NIST Cybersecurity Framework 2.0 that most security professionals, well, they already know it by heart.
Exactly. If you work in security, the CSF Identify, Protect, Detect, Respond, Recover is your Bible. This document, the Cyber AI Profile, is kind of like the commentary on that Bible, specifically for the Wild West of artificial intelligence.
So it bridges the gap.
It bridges the gap between standard cybersecurity and the unique, sometimes, frankly, bizarre risks that AI introduces.
And our mission today is very precise. We aren't trying to cover the entire document because we'd be here until next February.
We absolutely would.
We are going to act as your guides, specifically through Clause 2.4. That represents the identify function of the framework.
The identify function,
Yeah.
which is, it's arguably the most critical place to start. You can't build a wall if you don't know what you're defending, and you can't lock a door if you don't know where the house is.
Right. As the old saying goes, you cannot protect what you do not know you have.
And with AI, knowing what you have turns out to be a lot more complicated than just counting laptops.
So here is the plan. We are going to walk through Table 2 of the profile. We will move sequentially through asset management, risk assessment, and improvement.
Right.
But before we look at the table, we need to pick up our tools. The document uses 3 specific focus areas, think of them as lenses, to look at every single problem.
And this is a crucial concept. NIST doesn't just want you to look at a problem one way. They really want you to look at it through 3 distinct angles. These are secure, defend, and thwart.
Okay, let's unpack those. I want to make sure these are crystal clear before we start applying them. First up, secure.
Secure is short for securing AI system components. This is your defensive posture for the AI itself. It's all about managing the challenges when you integrate AI into your ecosystem.
So how do we lock it down?
Exactly. How do we lock down the model? How do we lock down the data? How do we make sure the AI doesn't break or, leak information? This is about protecting the asset.
Got it. So secure is about putting armor on the robot. Next is defend.
Defend is the flip side. It stands for AI-enabled cyber defense. This is about identifying opportunities where you can use AI to enhance your cybersecurity.
How can the AI help us?
It's asking that exact question. How can we use this technology as a shield? Can we use AI to be an analyst that never sleeps? Can we use it to spot patterns a human would miss?
So secure is protecting the AI, and defend is using the AI to protect us. That brings us to the third one, which has the best name. Thwart.
Yeah, it's a great word, isn't it? Thwart stands for thwarting AI-enabled cyber attacks, and this is the reality check.
This is acknowledging the other side has these tools too.
Precisely. The bad guys have the same tools we do. They have AI too. Thwart is all about building resilience against adversaries who are using AI to attack us faster, smarter, and with more scale than ever before. It's about understanding the offensive capabilities of AI so we can stop them.
Secure the AI, defend with the AI, and thwart the AI-enabled bad guys. That is our roadmap. We are going to apply these 3 lenses to every single row of the identify function.
Let's do it.
Okay. Section 1, asset management. The code is IDAM. This is the foundation. If you fail here, everything else just it falls apart.
It really does.
The first item on the list is ID.AM01, physical and environmental assets.
Right. This is identifying your hardware, your systems, your facilities, and yes, even the people involved.
Now, I have to play devil's advocate here. On the surface, this feels like standard IT stuff. I have a server, I put a barcode sticker on it. I know it's in Rack 4, row B of the data center.
Sure.
Why do we need a special AI profile for this? A server is a server, right?
You would think so. But when you look through that secure lens, the profile points out that, while yes, standard practices apply, AI hardware is different. It's a different beast entirely.
How so?
We aren't just talking about generic file servers. We are talking about high-performance computing. GPUs, TPUs, specialized accelerator cards like the NVIDIA H100s or Google's Tensor chips.
Okay.
These things run incredibly hot. They consume massive amounts of power, and they have very, very specific configuration requirements.
So it's not just where is it, but how is it running?
Exactly. The profile points you specifically to NIST SP 800-172 regarding configuration management. The point is, if you treat $1 million GPU cluster like a generic web server, you're going to have performance issues, or worse, hardware degradation that could affect your model's output in subtle ways.
Okay, that makes sense for secure. But what about the thwart angle? How does an AI-enabled attacker change how we look at a physical building or a server rack?
This is where it gets a little sci-fi, but also very, very real. The profile warns that adversaries might use AI to specifically target these physical assets.
Meaning what? A robot breaking down the door?
Huh?
A drone attack?
Not necessarily a robot, though. I mean, we probably shouldn't rule that out in the future. But think about reconnaissance. AI is incredibly good at pattern recognition.
Okay.
Attackers can use AI to analyze power consumption patterns of a facility.
Power consumption? You're kidding.
Not at all. Training a massive model causes a huge recognizable spike in power usage and heat generation. If an attacker can get access to utility logs or even publicly available thermal satellite imagery, they can use AI to map out exactly where your compute clusters are located inside a building.
Wow.
They can figure out when you're training a new model.
That is wild. So they can look at a heat map and say, that corner of the building right there, that's where the brain is.
Exactly. And once they know that, they can optimize their other attacks. Social engineering, for instance.
How would that work?
Oh, the cooling system in the North Wing seems to be under stress. Let me call the front desk, pretending to be an HVAC technician who got an automated alert. AI makes physical reconnaissance much faster and much more accurate.
That is a terrifying start. It really shows that asset management isn't just a spreadsheet anymore. It's counterintelligence.
It has to be.
Let's move to software. IDAM02. Software, services, and systems inventory.
This is a huge one. The core concept is simple. Maintaining an inventory of your software and services. But in the age of AI, this is, it's a nightmare.
Why a nightmare? Isn't it just another list?
Because of the secure challenge, shadow AI. The profile highlights that AI capabilities are very often embedded into existing systems.
Explain that for us. What does that mean, embedded?
Okay, so 10 years ago, if you bought software, you knew what it did. Microsoft Word processed words. That was it. Now, you might buy a CRM platform for your sales team or an HR tool for recruiting. You think you're just buying a database with a nice interface. But deep inside the code, often without a big banner on the front page, there's a machine learning model running inference.
Doing what?
Well, maybe it's ranking job applicants based on their resumes. Maybe it's analyzing customer sentiment in support tickets. Maybe it's suggesting sales leads.
So you have AI in your environment making decisions, processing your data, and you don't even know it's there.
Precisely. And if you don't know it's there, you can't secure it. You don't know where the data is going. Is that HR tool sending applicant resumes to a third-party API for analysis? If you haven't inventoried the embedded AI, you have a massive, massive blind spot.
That is the instructor insight right there. You probably have more AI than you think you do.
Almost certainly.
Now let's flip to the defend lens. How do we use AI to help here? Or maybe what do we need to track to enable a good defense?
So the profile suggests that your inventory needs to be incredibly specific if you want to use AI defensively. You can't just list CRM version 5.2. You need to list the specific AI models, the APIs they call, the keys they use, and specifically agents.
Agents is a buzzword we hear a lot. Let's define it in this context. What's an agent?
An agent isn't just a chatbot that answers questions. An agent is an AI that has tools. It can take actions in the real world, or at least the digital world.
It has hands.
It has virtual hands, yes. It can read and send emails, it can open files, it can run code, it can make calendar invites. If you are deploying AI agents for defense, say, an AI that automatically isolates infected computers from the network, you have to map their permissions.
Because if you don't,
If you don't, inventory which agent has the delete file permission, and that agent gets hijacked or, as we said, hallucinates.
deletes the whole database.
It cleans up the mess, which might be your entire customer list. So inventorying the permissions of AI agents is absolutely critical.
And the thwart reality here. What are the attackers doing?
The thwart angle emphasizes SBOM's software bill of materials. It's critical because attackers are using AI to scan your entire attack surface. They aren't looking for vulnerabilities manually anymore.
No.
They have AI bots that crawl the internet looking for specific vulnerabilities in specific versions of open source libraries.
So if that HR software we mentioned has an embedded, outdated version of, say, TensorFlow or some other AI library,
The attacker's AI will find it, and it will find it faster than your team will, unless you have a comprehensive SBOM that specifically calls out all the AI components and their versions.
it's a race. Transparency is the only defense against that kind of speed.
It is.
Let's move on to ID.AM03, organizational communication and data flows.
This is one of my favorite sections in the draft because it gets very granular about network traffic. It moved away from the abstract and gets right down into the packets on the wire.
And the Secured Deep Dive here offers some really actionable advice. They suggest categorizing network traffic into 4 distinct groups.
Right. And usually we just think internal and external,
Hmm.
maybe east, west, and north, south.
Okay.
But the profile says that's not enough anymore. You need 4 buckets.
What are they?
1, internal human-generated traffic. That's me browsing the company intranet. 2, internal computer-generated traffic, things like cron jobs, backups, automation scripts.
Predictable stuff.
Very predictable. Then, bucket number 3, internal AI-based traffic. And finally, bucket 4, external traffic.
I want to pause on the distinction between computer-generated and AI-based. Aren't they both just machines talking to machines? Why do we need to separate them?
Because of their behavior. A cron job is deterministic. It runs at 2.0 a.m. every night. It sends exactly 5 GB of data to the backup server. It disconnects. It has a static, predictable fingerprint.
Okay.
AI-based traffic is stochastic. It's inherently unpredictable. An AI agent might search the web, then hit an internal API, then download a file from a document store, then sit idle for an hour. It looks chaotic.
I see. So if you lump them together, the chaotic but legitimate AI traffic creates so much noise that it could hide a malicious bot that's also behaving chaotically.
Exactly. You've hit the nail on the head. If you treat AI traffic as just computer traffic, you mask the anomalies. But if you segregate AI traffic into its own bucket, you can establish a baseline for what normal chaos looks like for your AI.
Yeah.
Then you can spot the spikes that are truly weird.
And there's a specific tip here about supply chain attacks and external traffic.
Yes. You need to be tracking the traffic surrounding your model registries and dataset sources. Think about where you get your models and data from: Hugging Face, GitHub, NVIDIA's NGC, wherever.
Right.
If your AI server suddenly starts communicating with a server in a country you don't do business with, or starts pulling data from some repository you didn't authorize, that is a massive red flag for a supply chain attack in progress.
Now, let's look at the defend opportunity in this space.
This is where we get proactive. The profile says you want to maintain representations of AI data flows. Specifically, you need to map the path for inference requests versus training data pipelines.
Unpack that distinction for us. Inference versus training. Why does a network engineer need to know the difference?
It matters because the traffic profile is totally different, and therefore the risks are totally different. Training involves moving massive data sets. We're talking terabytes or even petabytes moving from a storage array to a GPU cluster. It's a heavy, wide, consistent pipe of data.
Okay, fire hose.
A fire hose, exactly. Inference, on the other hand, is when the model is serving users. You ask a question, it gives an answer. That's small, fast packets, high concurrency, very bursty traffic. It's like a bunch of little squirt guns.
Okay, I follow. Fire hose versus squirt guns.
So imagine you are monitoring the inference pipe, the squirt guns. Suddenly, you see a fire hose of data open up, a massive data upload, terabytes of data leaving the inference server.
That shouldn't be happening. Inference is just Q&A.
Exactly. That looks an awful lot like model theft. Someone is exfiltrating the weights of your proprietary model.
Ah.
Conversely, if you look at the training pipe, the fire hose, and you see weird, small, irregular injections of data coming from some unknown external source.
That could be data poisoning.
Precisely. Someone is trying to sneak malicious data into your training set. By mapping these pipes separately, you can tune your defenses, your intrusion detection systems, to catch the specific type of attack that is relevant to that stage of the AI lifecycle.
That is incredibly smart. It's behavioral analysis for the network, but specific to AI workloads.
That's a great way to put it.
Let's move to ID.AMS04, Supplier Services Inventory.
This connects back to the software inventory we discussed, but it focuses on the people and the companies providing the services, not just the code itself.
The secure angle seems pretty standard. It says standard practices apply, know your vendors, do your due diligence.
It does.
But the thwart angle raises the stakes significantly.
It does. It highlights adversarial risk. We have to realize that our suppliers and third parties are often the soft underbelly of our security posture.
How so?
Well, if you are a big bank, you have a digital fortress. You spend millions on security. But your AI chatbot provider, the startup you hired to build a sentiment analysis tool, maybe they aren't a fortress. Maybe they're a small company with 5 developers.
So the attacker hits the chatbot provider to get to the bank.
Precisely. It's a classic supply chain attack. The profile is very clear in this. If they get hit, you get hit. So your inventory of suppliers needs to include a risk assessment of their AI security posture.
So you have to start asking them some tough questions.
You do. You need to ask them, how are you securing your models? How are you vetting your training data? Show us your AI red teaming reports. You essentially become responsible for their hygiene.
Because in a connected AI ecosystem, risk is transitive.
Exactly. You can't outsource the risk.
Next up is ID.AM05, asset prioritization. This is all about ranking your assets, figuring out what's most important.
Right. The core concept is usually ranking based on mission impact. What keeps the lights on? What makes the money?
But the secure shift here introduces a new dimension, resource consumption.
Right. And that sounds a little odd at first.
Resource consumption, like how much electricity it uses?
Well, that's part of it, as we discussed with physical security. But here it's more about computing power and, critically, data sets. The profile makes the point that AI systems consume these resources in a way that contributes directly to their own vulnerability.
What does that mean?
It means that if your training data set is corrupted, the asset, the model itself, is now compromised. The data isn't just fuel for the asset, it becomes part of the asset.
So the data set is the asset.
The data is the code. That is the mantra you have to adopt. In traditional software, the asset is the compiled binary. In AI, the asset is the data that created the model.
So you need new classifications for these assets.
You do. You might have a critical classification for a folder of text files sitting on a file server. Because as that folder gets modified, your entire business logic, now encoded in an AI, fails.
And regarding the defend strategy for prioritization?
You have to prioritize your AI assets, the models, the inference services, based on their mission impact. The question the security team needs to ask is, if our AI-enabled defense goes down, does the whole network go dark?
That's a scary thought. If we start relying on AI to filter our firewall traffic and that AI crashes...
What's the fail state? Do we fail open, meaning everything gets through? Or do we fail closed, meaning nothing gets through and the business grinds to a halt? If we don't know the priority of that asset, we can't make that critical decision ahead of time. And you do not want to be making that decision while all the alarms are blaring.
No, you do not. All right, let's get to the big one. ID.AM07, data and metadata inventory. Our notes call this the heavy hitter of the identify function.
It absolutely is. In the world of AI, data is everything. And this section goes deep, really deep, into data provenance.
Provenance, that's a word we usually hear in art galleries. Knowing the history of a painting, who owned it.
It's the exact same concept. And it means the same thing here. Where did the data come from? Who touched it? How was it transformed on its way here? Under the secure analysis, the profile emphasizes the basics, like understanding consent and use agreements for data. But then it gets very technical. It says you need to track new types of metadata.
New types, like what?
Like in-memory data transformations.
Whoa, okay. Unpack that. That sounds like something deep in the weeds for a data scientist, not a security person.
It is, but this is where the sophisticated attacks happen, so security has to care. So imagine the pipeline. You have a clean data set on a hard drive. You've scanned it with antivirus. It's perfect.
Okay.
You load it into memory, into RAM to train your model. But usually, just before the data hits the neural network, there's a pre-processing step. Scripts augment the data.
Augment how? What does that mean?
They might rotate images slightly, or crop text, or inject a tiny bit of noise to make the model more robust, or they normalize the volume of audio files. These transformations happen in memory, on the fly, and they're usually considered harmless.
But the profile is saying they're not always harmless.
The profile is asking, are you tracking those transformations? Because if an attacker can inject a malicious script that subtly changes the data in memory right before the model sees it.
Your inventory of the files on your hard drive looks clean.
Correct. Your storage is clean, your file integrity monitoring says everything is fine, but your model is being poisoned in real time.
That is incredibly sneaky. So the inventory isn't just a list of files on a disk anymore, it's a list of processes and transformations that happen to the data as it flows through the system.
Exactly. The data on the disk is not necessarily the data the model sees. You have to verify the entire pipeline. And the risk here, the big one, is data poisoning. If that modified data enters the training loop, the AI learns the wrong thing. It could learn a backdoor.
And the profile warns about external sources too, which seems obvious but important.
Yes, training data originating outside the organization introduces massive uncertainty. Did you download that dataset from a verified university repository with a checksum? Or did you just grab it from a random GitHub link that was updated 10 minutes ago by user123? If you don't know the provenance, you simply cannot trust the model.
Now, surely there is a defend opportunity here. Can't AI help us manage this absolute mess of data?
It can, and it almost has to. The profile suggests using AI to help manage the data. AI is great at pattern recognition, right? So it can scan your petabytes of data to characterize its nature, map it to compliance risks, and identify sensitive data subject to laws like GDPR or CCPA.
So you use the AI to catalog the data that you're going to feed to the AI.
It's the only way to scale. Humans can't read 1 billion documents to check for PII, personally identifiable information.
Yeah.
But an AI can. It can tag your data for you, effectively building your inventory so you can protect it properly.
Okay, moving on to the last item in asset management. ID AM088. Systems and hardware lifecycle. This is birth to death.
Or cradle to grave, yep. Acquisition to disposal.
Right. The thwart angle here has a specific warning about outdated components.
It does. AI-enabled attacks will try to leverage your outdated and mismanaged components. There is a great concept here, a quote you could put on a poster. Old software is a playground for an AI attack agent.
That's a great quote. Why is it a playground?
Because AI agents can scan code and entire networks faster than humans ever could. They can find obscure, long-forgotten vulnerabilities in legacy software that we all forgot about 10 years ago.
So that old server in the corner that's still running because it's not hurting anyone.
It's a ticking time bomb. An AI attack tool will find it, will exploit it, and will use it as a beachhead to attack your main modern AI systems from inside your own network.
So the lesson is clean up your digital junk.
Ruthlessly. If you aren't using it, kill it. Decommission it. Otherwise, an adversary's AI will use it against you.
Okay, that wraps up asset management. A huge topic. We know what we have. Hardware, hidden AI software, traffic flows, data provenance, and all that old junk. Now we move to section 2. Risk assessment, IDRA. Now we have to understand the threats against those assets.
This is where we look at what could go wrong. And in the world of AI, the list of what could go wrong is getting longer and more creative every single day.
Let's start with IDRA 01, vulnerability identification.
So the secure reality here is that we have a new class of vulnerabilities. We aren't just talking about buffer overflows or SQL injection anymore. I mean, those still exist, of course.
Of course.
But now we have what you could call cognitive vulnerabilities in the models themselves.
Give us the list. What are the things that keep the AI security engineer up at night?
There are 4 big ones mentioned in the profile that everyone should know. First, adversarial input. This is basically tricking the model.
Like an optical illusion for a computer.
That's the perfect analogy. You put a specifically crafted, almost invisible sticker on a stop sign, and to a human, it looks like a stop sign with a sticker. To the AI vision system in a self-driving car, it looks like a speed limit 45 sign.
That is incredibly dangerous.
Extremely.
Yeah.
Second is model theft. This is stealing the weights of the model. Basically, copying the brain you spent millions of dollars and months of GPU time to build.
Right, and third?
Third is model inversion. This is where you extract private, sensitive training data from the model.
Model inversion sounds particularly nasty. So you can ask the model clever questions and it might cough up someone's social security number that it happened to memorize during training.
That's exactly what it is. It's a privacy nightmare. The model has memorized parts of the training data. If you ask the right questions or a long series of questions that corner the model's logic, you can get it to regurgitate that raw data.
And a standard vulnerability scanner won't find that.
Not a chance.
No
You can't just run Nessus on an LLM and find out if it suffers from model inversion.
And the fourth big vulnerability.
Membership inference. This one is more subtle. It's figuring out if a specific person's data was in the training set, even if you can't get their actual data out.
Why is that a problem?
Well, imagine a hospital trains a model on patient data for a study on a rare disease. If I, as an attacker, can use membership inference to prove your data was in that data set.
You've effectively diagnosed me with that disease without ever seeing my medical record.
Exactly. It's a huge privacy violation.
But the defend opportunity says we can use AI to fight back against this.
Yes. You have to use AI to find these new vulnerabilities. AI can analyze code for logic errors, it can identify semantic issues, and it can predict novel attack paths. It's basically fighting fire with fire. You need an AI red team that is constantly hammering your model with adversarial inputs to find these flaws before the bad guys do.
And the thwart angle confirms that the bad guys are already doing this.
Oh, absolutely. Adversaries use AI to find your vulnerabilities faster than ever. The profile says you need AI-assisted scanning just to keep up. It's an arms race. If they are scanning at AI speed and you are scanning at human speed, you lose. End of story.
Next up is IDRAE02, Cyber Threat Intelligence, CTI. This is getting information from the outside world about threats.
Right, and the key takeaway here is that your old sources are no longer enough. The profile lists some specific new sources that your threat intel team needs to be watching constantly. You can't just rely on standard CVE lists anymore.
What are the sources they call out?
The OWASP POP 10 for LLMs. That is your Bible for large language model security. The AI Incident Database, or AID, which is a fascinating if terrifying read. It's a public catalog of every time an AI has failed or caused harm in the real world.
That sounds like important context.
It is. And finally, MITRE Atlas, which maps AI attack tactics and techniques, similar to the famous MITRE ATK and CK framework that so many security teams use.
And there's a specific risk mentioned here about LLMs executing code. This seems to be a big one.
Yes. This is a huge operational risk. LLM-based systems can operate autonomously and might execute arbitrary code inside a compute environment.
Meaning the chatbot writes a script and just runs it on the server.
Yes. Think about features like code interpreter or advanced data analysis that are common in chatbots now. You give an LLM the ability to write and execute Python code to solve math problems or analyze a spreadsheet.
Okay.
An attacker can use what's called prompt injection to trick that LLM into writing Python that opens a reverse shell back to the attacker or scans your internal network for other vulnerable systems.
So you trick the AI into becoming your own personal hacker inside the company firewall.
That's the attack. You need threat intel that tells you how these prompt injection attacks are evolving so you can build defenses against them.
And under thwart, we have to talk about phishing. It always comes back to phishing.
It always does.
Yeah.
But here we have to emphasize the dramatically increased risk. AI-enabled phishing is faster, better, and hyper-personalized. It's not just a generic email from a Nigerian prince anymore.
No.
It's an email that looks like it's from your boss, referencing the specific project meeting you just had 5 minutes ago, written in their exact writing style.
Because the AI scraped your public LinkedIn profile, the company blog, your boss's tweets, and it learned their voice.
Precisely. It's social engineering at a massive automated scale. The likelihood of a successful phish has just gone through the roof.
Moving to IDRA03, internal and external threats. This is about identifying the actors.
And also the non-actor threats. The secure shift here introduced a concept called drift.
Concept drift. Sounds like a sci-fi movie title. What is it in this context?
It's when the model gets out of sync with reality. So you trained your AI to detect email spam in 2024. By 2026, spammers are using new techniques, new language. Spam just looks different now.
Yeah.
The model hasn't changed, but reality has. The model is now drifting towards failure. That isn't a hacker attacking you, that's just entropy. But it is a security risk, because the model starts making mistakes, letting threats through that attackers can then exploit.
And what about feedback loops? That's another term they use.
Amplifying feedback loops. This is fascinating and devious. Imagine an AI that's learning to detect threats on your network. It blocks a certain type of traffic. The bad guys see this, so they change their tactics slightly. The AI then learns from this new traffic.
So it's adapting. That sounds good.
It sounds good, but if the bad guys are clever, they can train your AI to ignore their real attack. They do this by feeding it carefully crafted noise that slowly shifts the AI's boundary of what it considers normal.
That is devious. It's like boiling a frog. You teach the guard dog to ignore the burglar by having him walk past the fence every day for a month until the dog just gets bored and stops barking.
That is a perfect analogy. You are desensitizing the model to the real threat.
The thwart reality here mentions script kiddies. How do they fit in?
AI dramatically lowers the barrier to entry for sophisticated attacks. You don't need to be a master coder to launch a complex attack anymore. You just need to know how to ask a jailbroken LLM to write the malware for you.
So the threat landscape has expanded to include, well, almost everyone with a laptop.
It really has.
IDRA 04. Potential business impacts. What happens if things go boom?
We all know the classic CIA triad: confidentiality, integrity, availability. But the profile says with AI, you have to add a whole new list of potential impacts.
Such as?
Hallucinations, when the AI just makes things up, but states them with complete confidence. Bias, when the AI makes unfair decisions, like denying loans to people from a certain demographic. And a huge one, lack of explainability.
The black box problem.
The black box problem, we don't know why it did that, is a terrifying impact for a business. Imagine trying to explain to a regulator, why did we deny this person's loan application? And your only answer is, the computer said so.
That is a regulatory fine waiting to happen. It's a reputational disaster.
It is, and under Defend, the profile suggests using AI to simulate these scenarios. Let an AI model predict the business impact before it happens. Run simulations. What if our model becomes 10% more biased? What does that do to our revenue? What does that do to our legal liability?
Use the tool to predict its own failures.
Exactly.
IDRA 05. Risk likelihood determination.
The thwart shift here is very simple. The likelihood of almost all attacks increases because AI makes it easier to attack.
The effort goes down.
The effort goes to near zero.
Okay.
And the scale. AI enables attacks at a speed and scale that humans cannot possibly match manually.
So if you're calculating risk and you think this attack is unlikely because it takes too much manual effort, you are using an outdated model.
Correct. Your risk calculus is wrong. You have to assume that any attack that can be automated will be automated by AI.
IDRA 06. Risk response prioritization. Deciding what to do about all this risk.
The defend strategy here has a crucial constraint. It says you must define conditions for disabling AI autonomy during a risk response.
A kill switch.
A kill switch. You don't want a runaway AI trying to fix a runaway AI. If your AI defense system is actively fighting an AI-driven attack and things are going sideways, you need a human to be able to step in and say, stop, everyone freeze.
It's the classic keep a human in the loop rule.
Especially during a crisis. You cannot abdicate that final responsibility to the machine when the machine itself is under attack.
IDRA is 07. Managing changes. Configuration control.
This brings us back to that idea of the butterfly effect and the secure insight. Even tiny, seemingly insignificant changes to an AI system can introduce unknowable risks.
Like changing one number in a configuration file.
A single hyperparameter, a learning rate, or slightly changing the composition of the training data. You cannot predict the impact of a change without retesting the entire result.
It's not like normal software.
Not at all. In standard software, if I change a font color from blue to red, I'm very confident the database isn't going to crash. In AI, if I change a model weight by 0.0001%, the model might suddenly stop recognizing faces entirely.
So what is the requirement then?
Version control everything, and I mean everything. The hardware configuration, the software, all the configuration values and hyperparameters, and most importantly, the training data. You need to be able to roll back the data to the version from last Tuesday.
That sounds incredibly expensive. Storing multiple versions of these massive data sets.
It is expensive.
Yeah.
But the alternative is having a corrupted model that you can't fix because you overwrote the last known good data. For an AI-centric company, that's an existential risk.
Last one in the section, IDRA 09, authenticity and integrity. Verifying your hardware and software is real.
The thwart threat here is frightening. Counterfeit hardware or software could introduce a malicious AI directly into your environment.
Like a fake GPU chip with a hardware backdoor?
It could be that. Or it could be a fake open source library. You think you're downloading PyTorch, but it's a version someone has tampered with to include a backdoor. Because AI systems are often black boxes, we can't easily see inside the math. Verifying their integrity is much, much harder than with traditional software. You can't just read the code because the logic is buried in billions of numerical weights.
Okay, we have identified the assets, we have assessed the risks. Now we move to the final section of Identify. Section 3, Improvement, IDIM. This is about learning and adapting.
This is how we get better and close the loop.
IDIM there's 1, Evaluations and metrics.
So the secure section here dives into what our notes call the math of security, and it's so important.
It warns specifically about the metric trap.
Yes, it says that relying on a single metric, like an F1 score, might obfuscate the results and give you a false sense of security.
Explain that for the non-mathematicians among us. What's an F1 score and why is it a trap?
Okay, stick with me. An F1 score is a statistical average. It's a blend of two other metrics, precision and recall.
And what are they?
Precision asks the question, when my AI says it's a threat, is it really a threat? It's about minimizing false positives. Recall asks, of all the real threats out there, how many did I actually catch? It's about minimizing false negatives.
Okay.
If you just look at the average of those two, the F1 score,
Right.
you might miss a very dangerous problem.
Give us an example.
Imagine you have an AI looking for computer viruses in email attachments. It's fantastic at its job. It catches 99.9% of all viruses. That's a high recall.
Sounds great.
But maybe it also flags 50% of legitimate spreadsheets from your finance department as viruses. That's a terrible precision. Your F1 score might look okay, but your finance team can't get any work done. Or the other way around.
The more dangerous way.
The more dangerous way. Maybe it has perfect precision. It never flags a good file.
Right.
But it only has 50% Bactrican. Recall, it misses half of the actual viruses. Your dashboard might show a 90% success rate based on some blended metric, but you are actually getting destroyed by the 50% of threats it misses.
So the single metric hides the specific critical failure.
Exactly. You have to make a conscious decision. Is a false positive, crying wolf, worse than a false negative, missing the wolf?
In cybersecurity, usually missing the wolf is way worse.
Usually. But if crying wolf shuts down your factory production line 50 times a day, you have a different, very expensive problem. The profile says, pick your metrics carefully. Don't just trust the single accuracy number on the dashboard. Dig into the precision and the recall.
I am so too. Testing and exercises.
The key word here, and it's a big one, is AI red teaming.
This is explicitly mentioned in the profile.
It is, and for good reason. You absolutely need to attack your own AI. You need a dedicated team whose entire job it is to try and trick the chatbot into being racist, or to trick the vision system into seeing that stop sign as a speed limit sign. If you aren't red teaming it, you can be sure the adversary will be.
And it's not just your own AI.
No, you have to coordinate with your suppliers of models and data to harden the entire supply chain. Red team their stuff too, with their permission.
And finally, let's talk about ID.IML4, incident response plans.
So the secure specifics here note that AI incidents require their own specific procedures. Your standard IT incident response plan probably doesn't cut it.
For example,
Restoring stable model backups.
we talked about versioning.
Yes. But note the nuance here. It's not just code versioning, it's dataset versioning. You might need to roll back to a previous dataset. If your AI starts hallucinating and giving out dangerous financial advice, patching the application code won't fix it. The problem is in the model's brain. You need to revert the brain of the AI to the state it was in before it ingested the bad data.
So you have to perform a kind of digital lobotomy and restore the memory from a week ago.
That's a great, if slightly grim way of putting it, but yes, that's exactly what it is.
Wow. That brings us to the end of the table for the identify function. We've walked through asset management, risk assessment, and improvement.
It's a lot to take in, but if you step back and look at it all, the pattern is very clear.
So let's synthesize. What does this all mean for the listener who's been following along? What's the big takeaway?
The identify function in the AI context is all about expanding your definition of an asset. It's not just boxes and wires anymore. It's the models themselves. It's the data flows. It's the training sets. It's the incredibly complex relationships between all of them.
And you have to look at it through those three lenses.
You have to.
You have to lock down the data and the configuration as if they were source code.
You have to use AI to find the needle in the haystack, because the haystack is now petabytes in size and growing exponentially.
And you have to operate with the assumption that the bad guys are using the same powerful tools you are, but they don't have to follow any of the rules.
It really emphasizes that you can't just bolt AI onto your current security plan. You need to fundamentally rethink the plan around the unique nature of AI.
Precisely. And everyone needs to remember this is based on the preliminary draft from December 2025. This field is moving at an incredible speed. The standards are trying to keep up, but the technology is always going to be a step ahead. You have to stay vigilant.
Before we go, I want to leave the listener with a final provocative thought. We talked a lot about data provenance.
We did. It's really the core of the whole issue, I think.
So here is the thought. If you don't know where your data came from, or you don't know how it was transformed in memory before it was used for training. Do you actually know who is controlling your AI?
That's the question, isn't it? Is it you? Or is it the person who poisoned the well 3 steps back in the supply chain?
If the data is the code, and you didn't write the data, you didn't write the code, someone else did.
And that is a chilling thought to end on.
On that note, thank you for joining us on this instructional deep dive into the NIST Cyber AI Profiles Identify function. We'll be back next time to tackle the Protect function. Until then, keep your models clean and your inventories updated.
Stay safe out there.